treasure, it's a natural treasure as well. So it's a complex system that intertwines an eclectic mix of culture, of history, of economy, and also the environment. So our panel today is going to talk about a lot of that and even more. So they really don't need an introduction. However, I'm going to let each panel member introduce themselves and tell you a little bit about their career, their understanding of the Chesapeake Bay through their lens, and what their expertise has been as well. So again, just to tell you about this panel, as you can see in your program, it's from 9 to 10:30 a.m. So my main job is to keep us on time because this sets the entire stage for the rest of the day. So with that being said, we're going to start with introductions. After that, we have a group or a round of prepared questions, and then we want to hear from you. We will have an opportunity for the audience to provide questions as well. And then we'll wrap up at 10:30 so that we can continue the activities of the day. Sound good? Okay, I like interaction. Sound good? Yeah. All right, I love it, I love it, I love it. Okay, so we are going to introduce our panelists in alphabetical order, and that's what you see in your program. So as I introduce you, I will give you a few minutes to just say a little bit about yourself. So our first panelist is Walter Boynton, Professor Emeritus, Chesapeake Biological Laboratory at UMCS.
Hi, thanks, Kandis. Lordy, what to say in just a couple of minutes. Generally, we're used to talking for hours, so I've got less than 4 minutes. We'll deal with it. I come from a salty family. My dad was a commercial fisherman before the Second World War. One of my brothers became a commercial fisherman. Another brother was a Coast Guard officer. He ran Coast Guard cutters for most of his career. And then there was me, marine science. So we're kind of watery. When I finished undergraduate school, I had no idea what was going to happen. I was not one of these people that had career goals. I figured I was going to get drafted into the U.S. Army, and we would see where it went from there. As it turned out, I did apply to 5 graduate schools. I got turned down at all 5 of them. But I also applied to the Chesapeake Biological Lab for a summer internship. And in my mind's eye, I was going to become a second Jacques Cousteau instantly. Anyway, it turns out that what they wanted someone to run the Xerox machine. And so my first summer in marine science was doing this, and I'll tell you, I got really good at it. I could run that Xerox machine right into the ground. And I was Xeroxing things for a new manual on identifying fish eggs and larvae along the east coast of the United States. And that tells us something about where the science was at that time. It was not readily, we were not readily able to identify a lot of these little critters at the early life history stages back then. So working at the lab was wonderful. I fell in love with marine science. I had a sense of where I was going, and I went off to graduate school. And then the fickle finger of fate came into play, and when I was finishing, a friend at CBL called up and said, "Walter, we've got a job opening here. Would you like to apply?" I did. My wife and I thought, well, we'll be there for a few years, and 40-some years later, we're still there. And one of the reasons is that the Chesapeake Bay, the academic world, the management world, the political world here is basically interested in the environment. So it is a relevant place to work, and I loved it. I'm going to finish with a quick story because I see a lot of young faces out here, and this is, well, a couple of older faces, but thankfully there are a lot of young faces. So when I was starting graduate school, my advisor, who was a very formal man, and like me, of course, he said, "Walter," actually he used to call it by our last name, he said, "Mr. Boynton, you need to present a paper at a conference. The time has come." I was scared to death. So I put together this talk. I went to the Atlantic Estuarine Research Society meeting. I was sitting in the audience. They called my name. A friend sitting next to me said, "Walter, you dummy, they're calling your name. Get up there and do the thing, you coward." So I went up to the stage. I gave a horrible talk. I'm told that occasionally I pointed like this at some slide that was on the screen, unrelated to what I was saying. I was talking like a gerbil on crack. And eventually, fortunately, the talk came to an end, and I stepped back and fell off the stage. I landed on the floor, and all kinds of cobwebs and electric cables and curtains surrounding the stage. And I was knocked semi-unconscious, and I'm laying there thinking, this is not good. This is not a way to start a career. And so I put my hands up onto the stage and pulled myself up, and I'm looking out at the audience. And because I think I was still moving, they applauded. They thought, this is great. He's alive. And so I crawled up onto the stage. I thanked them and went and sat down. And my friend looked at me and said, so what's your next trick, Houdini? Anyway, I'm telling you this silly story simply because things get better. And as scientists, often we have discouraging moments. Just keep plugging away and things will get better. Anyway, thanks, Kandis.
That was a great introduction. Better than anything I could have done, right? Exactly. So. All right, our next panelist is Tuck Hines, who is the director of the Smithsonian Environmental Research Center. The floor is yours.
Thanks, Kandis, and thanks everybody for being here. It's great to see you. Difficult act to follow after Walter, but I arrived in Chesapeake Bay 44 years ago, a bit over 44 years ago, coming from the West Coast, having gone to graduate school in the halcyon days of free speech movement, hippie world, Vietnam War protests, and a lot of the violence of those times. We think of things being very violent now, but on campus there were daily riots in Berkeley. I'd grown up in Hawaii. When I arrived in Chesapeake Bay, a very different system, even from San Francisco Bay, where I'd been working. And so it was a very new system to me. And I came to a small place that was an abandoned dairy farm with really very poor facilities that have changed over time in the last 40 years. Now, as a director, I came up through the ranks as a research scientist working on population and community ecology of the fish and invertebrates of Chesapeake Bay and many other systems in the coastal zone, particularly on blue crabs, which were the most lucrative fishery at the time and still arguably at the price $500 a bushel. That's amazing. Then crabs were $25 a bushel, and even accounting for inflation, that was a lot cheaper. But at that time, the old guys were the people that really founded an understanding of basic understanding of estuaries. Gene Cronin, Pritchard, and Hargis at the three main facilities on the bay, the main labs. And those were the ones that defined what an estuary is. Pritchard's definition stands today as semi-closed enclosed body of water into which fresh water and salt water from the sea mix. Pretty simple thing, but how that works physically and chemically is really important. But when I arrived, I was amazed at how little we knew. We knew almost nothing about the life cycles. Even blue crabs, we had basic understanding, but we didn't know where the larvae went. We didn't know much about what migrations or anything else. And we knew very little about the chemistry of the system as a whole and the interaction with the land. So I think part of the story today that we'll talk about is how much things have changed and how far we've come, and how those folks at the start of the directors of those laboratories and the scientists that were there came to understand much more about the bay. And much of that is due to the emphasis of the Chesapeake Bay program with federal funding and expanding that to understand the watershed states and the District of Columbia for Chesapeake Bay as a whole system rather than small pieces and parts. So my role as director has been to keep everybody out of jail, enable their opportunities to go and get good grant money, and to promote the best possible science that we can, and to train the next generation of scientists and research managers, resource managers like yourselves.
All right, thank you so much. Our next panelist is Mark Luckenbach, who is the Professor and Associate Dean of Research and Advisory Services at VIMS.
Well, thank you, Kandis. First, I appreciate the invitation to this and to sit at this table with some very esteemed colleagues. I had some pretty dull things that I was probably going to say. Just you took a few things off your resume, but I can't keep up with Walter, but I'll switch gears a little bit. I grew up on a cattle ranch in South Texas, and I didn't know anything about salt water. I went to college and ended up getting a degree in zoology, but really got interested in community ecology. In graduate school, I just happened to do that community ecology on the coastline in Bear Island Salt Marsh Lagoon System. And as I was finishing, the year I was finishing it, there was, finishing the PhD, you're kind of frantic, you're applying a bunch of jobs, you're trying to write postdocs. Walter said he applied to 5 and got rejected to all of them. I think I put in a combination of 20 between job, positions, postdocs, writing postdocs. I either got rejected or just ignored by 17 of them, but that left three to choose from, and I chose what was really a relatively small but great reputation at that time, Virginia Institute of Marine Science. I didn't know how long I would stay there, but I arrived in 1985, not knowing much about the Chesapeake Bay. 2 years after the Bay Agreement had been signed, and as a marine benthic ecologist who did experimental stuff, I did some work in the Bay, but benthic ecology was kill them and count them mostly in the Bay. We weren't very experimental, and I gravitated a little bit to the VIMS Eastern Shore Lab out on the Bear Island Salt Marsh Lagoon System that I knew a bit about. It was a small little field lab. I was glad they had it. I'd like to use it. So when VIMS was preparing to close it down a few years later, and I suggested otherwise, and then anyway, they ended up advertising for a position for it. I didn't apply, but the director told me to, and I spent 23 years not focused as much on the Bay as my colleagues here, certainly doing some work in the Bay, but doing a lot of work in the coastal Bay system. But along the way, as a marine benthic ecologist, what I've done and largely worked in and was doing work in was restoration ecology, some with oysters and some with seagrasses and later years some bay scallops into those seagrasses. But early on in my career as well, the then dean and director of VIMS asked me if I would look after the oyster hatchery for a month or two. I didn't know anything about oysters. But I could quickly tell they were I felt like they were doing, and it had no training, no scientific training in it. They were doing a technically good job of trying to solve the wrong problem, which was to fix a wild fishery, to fix the bay with a hatchery. That month or two turned into 10 years, started the oyster aquaculture program at VIMS, and with a real focus on farming, mostly with what I learned on a cattle ranch in Texas, not in graduate school, and it's a pleasure to see where that's gotten to at this point. I will echo what's already been said, that there was so much we did not know about the Bay system at that time, and there was so much to do, and I, despite being out in the Bear Island Coastal Lagoon System, I did maintain programs in the Bay, and it's been remarkable to see how much we've learned. We'll later talk about things we missed and things that we need to do, but in big picture, it's been amazing, the work that's been done, and by so many people, and the value of the Bay program, which has already been mentioned, in keeping that going, because you just can't do this stuff without the dollars to support the science. So I'm looking forward to the day and hearing other folks.
All right, thank you. And our fourth panelist is Mike Roman, Professor Emeritus at UMC's Horn Point Lab.
You know what Professor Emeritus means? It means you don't get paid, but they still expect you to do a little work. So, yeah, my research is supported by TIAA CREF. It's a retirement agency. I came to Chesapeake Bay in 1981. I was at the University of Miami, and it was too hot and too crowded in Miami. And now it's too hot and too crowded here. So, I don't think I'll move up to Maine. But yeah, I first came to the Chesapeake Biological Lab in '81, and I remember they would have a summer picnic, and we met at this place on the cliffs, at Calvert Cliffs, and you overlook the bay. And it was about the second week I got there, and you look down in the bay, and they go, "Look at those schools of menhaden," and they were like acres and acres large, just huge schools of menhaden, and we don't have those anymore. And Ed Hood used to take me fishing and catch bluefish and striped bass. And then shortly after that, we had the moratorium on striped bass. They kind of reorganized ocean sciences. I'm an oceanographer, and I moved over up the road in Cambridge at the Horn Point Lab in '83. And, I had bay projects and both here and Gulf of Mexico and the Baltic. I studied low oxygen water, and then foolishly or wisely, I don't know, I became director in 2001, September 1st, 2001. And then, of course, 10 days later, we had the tragedy of the bombers, and then our budget was cut 20%, and it was a disaster my first year as a lab director. But I persisted from 2001 until last fall when I stepped down as director. And so now I've got a couple of fun science projects, which is kind of why I got into this business in the first place, with younger scientists, one at University of Virginia and one at Horn Point, studying low oxygen effect on marine food web. So it's going to be fun in my retirement phase to get back out on a boat and start sampling again. That's it.
All right, thank you. All right, so let's start with some prepared questions that we provided to our panel in advance. So for this first one, I'd like Tuck to start the conversation off. And the question is, as you've heard, many of our panelists have dedicated their careers to studying the Chesapeake Bay. So while there is still much work to do, what are some of the positive aspects of science and restoration that you have witnessed?
It's interesting. We tend to emphasize the negative things, the bad reports from the Bay program every year of maybe a C, a D on this, and an F on that, and all the doom and gloom of things that are confronting us with fisheries and pollution and climate change and all that. And I get all that. We should certainly focus on some of those issues today and going forward. But it is useful from our longer-term perspective to think about how things have changed and how much we've learned. In part, that's because science has changed a lot. The technology of computers, of satellites, of much better instrumentation, microscopes, being able to analyze and commonly use DNA to identify species. Our perspective of a much more holistic view of the Bay, as I said, the Bay is not just the estuary itself, but the whole watershed, 64,000 square miles, 6 states, District of Columbia, all the governmental entities that are involved in that, and the challenges of coordinating that. The population in that time, human population in that time, has doubled. So, when you look at the Clean Water Act, the Clean Air Act, many of the other things that have come in from legislation and the awareness of fishery management and pollution measurement problems and the monitoring program that's in place have really created a tremendous amount of better, more holistic, and much more scientific and detailed understanding that's quantitative and able to measure change going forward. Yes, there are some problems going forward that are enormous. But if you look at the reduction, for example, of nitrogen coming into the Bay as a result of the Clean Air Act, We have many more vehicles emitting into that. We're about to transition now from combustion engines into electric vehicles, which should help even more. But the reduction of fossil fuel power plants and all of those changes that have happened are huge improvements to the Bay that if we had not committed to doing that 40 years ago, 1972, under then Reagan administration, would be much worse off than we are. So I think technologically, I think from a policy point of view, scientifically, and from the public's awareness of what the environment of the coastal zone, these connected ecosystems in the coastal zone is where 70% of the world's population live, where most of our urban centers are located, as port cities that are the centers of commerce, where 90% of commerce comes by shipping across the ocean. So thinking about those things in a positive sense is useful, that there's hope for us in the big challenges that are facing us, as insurmountable as they sometimes seem today.
All right, thank you. Walter, would you like to follow up on that?
Sure. I'm just going to add a few specifics to what Tuck has said. I agree with everything he has said. One of the things I would point out is that during the 1950s and 60s, there was almost no literature about estuaries. Estuaries were a black box. We knew almost nothing in terms of a robust, rich scientific literature. That has changed monumentally, and that's for the good. One of the things that took a while was to recognize that estuaries could be polluted. This sounds crazy nowadays, but back then, that was not a crazy statement. That was something that leaders needed to be convinced of. In fact, in Maryland, the Department of Natural Resources policy was to follow the agricultural model, and that is, if farmers put nitrogen and phosphorus on fields to get a crop, if they added more nitrogen and phosphorus, they got a bigger crop. So we needed to get busy dumping nitrogen and phosphorus in the bay to increase the crops. So the policy was to increase the amount of nitrogen and phosphorus going into the bay, and that was a strong policy. Academic people came close to getting fired for saying, no, 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 this is causing problems. So recognizing the problem was, that was a big deal. And it got recognized and really formalized when the Bay program started. That was a really important step. A second point is that I think a lot of this is the science stuff, the causation, what causes what, became clarified. So it became clear that of the 8 ideas that were being talked about what killed off the seagrasses, we finally got to a point where we think we had a pretty good understanding of what killed off the seagrasses, what the primary causes were. That was very important. When rockfish populations started taking a dive, there were lots of possible explanations. Science sorted those out and said, overfishing is the problem in this case. There was one other one in terms of improving water quality, in the 1950s, 60s, 70s, and into the 80s, the idea was that only one nutrient needed to be controlled, and that was phosphorus. You were nuts to think about dealing with nitrogen. And I think that particularly the Bay science community really cracked that nut. And the policy that the Bay program, the states adopted, was a dual nutrient reduction strategy, which I think is wise. That is, both nitrogen and phosphorus in these systems that sit between the land and the ocean, you got to deal with both of them. If you don't, you're going to be missing the boat. So that became policy. Those were all important. Technology is the last thing I'll say. When I was trying to become the second coming of Jacques Cousteau and failed miserably, I was doing nutrient analyses along with running the Xerox machine. And if I had a great day of doing nitrate analyses, I could do 20. That was a great day. And some of you oldie goldies out there might remember those days. In the same laboratory now with the new technology, if they have a great day, they can do 800. We used to take and make 13 water quality measurements of surface water quality variables along the Patuxent estuary once a month. With the data flow system now, in less time, they can make 3,600 measurements. We used to take and make at the same estuary about 13 surface water measurements of dissolved oxygen every month. Now we make about 30,000. So we can look in the finer scales of variability, which are all real important. So super big advances in technology and understanding. Done.
All right, I like it. All right, we'll move on to the next question unless there's any other comment.
The only little exclamation point I would put on that is I recently ran across a advisory pamphlet bulletin published by the Virginia Institute of Marine Science in 1960 about how to get rid of nuisance seagrasses.
How big was it?
How to get a little bitty thing. It was just how to teach the public how you could get rid of those nuisance seagrasses.
Yeah.
We didn't think they were important.
Can I ask a question?
You were.
May I ask a question?
Yes,
Since you love interaction, I want to help.
go for it.
Was the policy truly to increase nitrogen in the bay, or just they were not paying attention to it and didn't think about it?
Jim Coulter was a very fine man who was a secretary. He was in favor of increasing. That
So
was the,
how would a higher concentration in the water assist farming on the land?
no. I'm not being clear. Putting more nitrogen and phosphorus in the water would increase the productivity of things in the water.
Like it did on the farmland?
Exactly.
Okay.
Yes.
Okay.
Yeah, sorry. I've been accused of being vague and confusing before. Good, thanks for the question.
All right, let's move on. So for our next one, Mark, how about you take this one? How has climate change shifted the way we think about the Chesapeake Bay from a partnership, a social, and a restoration perspective?
Well, first of all, shifted is certainly the right word to use because it wasn't in the thinking process initially. Remember when I spent a decade or more serving on the Scientific and Technical Advisory Committee to the STAC to the Bay program, and we had that committee beat the drum for a while to try to incorporate explicitly climate change into our understanding of that into where we thought we needed to go and how it would affect our endpoints. And I have to say the Bay program has made great improvements on that, first of all, but very specifically in the 2024 Chesapeake Bay Watershed Agreement, it calls it out. And I'm just going to quickly read down some bulleted things they've done in that time because they're really important. Established a Climate Resilience Committee. Incorporated climate change into TMD model framework. Projected future intensity, duration, and frequency of precipitation, and serve it out on a web-based tool for the entire Chesapeake Bay watershed. And that kind of thing really adds. I mean, it has value. That not just background science. It really adds value in aids in stormwater management planning, among other things. The list is still long. They've begun evaluating how the climate change impacts our BMPs, our agricultural BMPs, urban, natural BMP performances, and maybe most importantly, the uncertainty around what we think they do, which is another key point there. It started making us think a lot more about the uncertainty associated with these projections. In notes, there's just lots of bullets to hit that the Bay program is really, when working hard at this, putting together work groups, initiating studies. In the few minutes I have, there's a long list of things. I'll talk about a little bit more about the science, or maybe some of the particular topics. We could spend the whole conference just on this. There's obvious things that increasing temperatures are going to exacerbate hypoxia and anoxia conditions in the Bay. We've already seen that in some cases in bottom water. One of the most important things I think and I think I'll give you the reason why, is this intensification of storms and frequencies. Those even recent enough that I think even the young people in the audience will remember what Hurricane Harvey did in Houston, Hurricane Florence did in North Carolina, just dumping huge amounts of rain. We haven't had one of those in recent years, but we've got a very real example. Tropical Storm Agnes in 1972 dumped when I was in high school, but dumped an enormous amount of rain on the watershed. And that caused changes to the fauna and flora, some of which we still see today. There are species shifts that haven't changed from that. So if that type of event is going to become much more common, then we need to really actively be planning for that and thinking about managing that runoff and how we can possibly do it. Because that was really a huge event in the Bay. The other thing we're seeing a lot of, we expect to see and we are seeing, are shifts in species ranges. That may pose, mostly shifts, of course, to the north. It may pose some, challenges for management, but it's not all bad. I mean, we don't have as much summer flounder, unfortunately, in the lower bay, but boy, we got a lot of shrimp. When I came here, there were occasionally shrimp came up, made it from south, but they weren't reproducing here. They're among the most abundant organisms that we collect in the lower bay in our juvenile trawl surveys annually. Now, and fortunately, I think lessons have been learned elsewhere in the past, and we're not going to have shrimp trawlers in the bay. We certainly hope, but that doesn't mean there isn't going to be some political pressure to do it. An interesting threat that I think is worth thinking, this is one to think about or to consider. As we see these shifts in species, which again is natural, and we're seeing it both in some of the fisheries and mobile, they're shifting northward, but we're also seeing centers of populations some species not come into the bay as much. Again, probably a temperature phenomenon, but we don't know all the reasons. But as these mobile species shift northward, and we start to see more pigfish and pinfish, et cetera, in the lower bay and Chesapeake Bay, the foundation, and the shrimp as well in some cases, that if the foundational species, like the seagrasses that they depend upon for nursery areas, aren't shifting as quickly, certainly if eelgrass becomes extirpated from the lower bay by temperature eventually, typically those foundation species don't move as fast. I contend there's a time, in fact, we've got people now studying the physiology of haladuli, shoalgrass, to the south, because we tend to take a cue from what we've seen in terrestrial situations in which those foundation species don't move to as high a latitude or as high of altitude as quickly as the organisms that depend upon them. We're gathering some of the data to understand when and how to maybe help that shift happen. I've probably run out of time, but I'll add one other really quickly. It might surprise some people in here. Big picture, Maryland and Virginia's tidal areas, tidal watershed of the bay. In the last 150 years, there's been no net loss of seagrasses. Of tidal marshes. There's been a lot of loss, but there's been a lot of gain. That's come at the expense, as marshes have migrated, that's come at the expense of coastal forest and coastal agriculture. And it's managed to keep up for the last 150 years. With the accelerating rates, we're going to need to pay much more attention to corridors for those marshes to migrate, because they are drowning faster and they're eroding faster. It's probably counter to what you thought, that there's been no net loss of tidal marshes in that period. But that's not going to be true for the next 150, not even the next 50, if we're not a little more active and thoughtful about areas for migration upward. I'm sure I'm out of time at this point. So.
No worries. Actually, follow up. Walter, would you like to?
Sure. Let me start with just saying a few words. from a fellow who was a poet and a songwriter and educator, a fellow named Tom Wisner, who passed away a few years ago. And when Tom was thinking about bay restoration in terms of reducing the amount of sediment, nitrogen and phosphorus getting into the bay, and he was in a discouraged mood, which occurred to him quite often. He said that restoration in the bay was somewhat like walking south on a fast-moving northbound train. In other words, you think you're making progress at walking south, but the world is shifting right underneath you. It's getting worse. We're on a fast-moving, developmental, focused train. And in terms of that issue, I think Tom was wrong. He was wrong about a lot of stuff, but he was wrong about that one. Recent reports indicate that loads have come down. It's taken a hell of an effort to do that. So now we're talking about climate change, and that's layered right on top of this really difficult task of both managing the food webs, the habitats, and the water quality. So it is a challenge. It is a really big challenge. I just want to say that I think that's the challenge for the next generation, and whatever gas we've got left is trying to manage that. That's a real toughie. So one of the things I think we could do that I am pretty optimistic about is that the ability of people to use in very productive ways mathematical models of the bay and the landscape. We need to really push on that. That's my opinion. I remember when the first models, water quality models, came out. I'm that old, and they were they were terrible. And the big thing they did was they didn't work, and that was incredibly helpful because it just held people's feet to the fire. It said, we are missing things. We do not understand the system as well as we need to. And so those models were useful from that point of view. The first of those models, I remember, divided the main stem bay into, I think, 9 chunks. I think we're up to something like 55,000 chunks now. The reason for that is not because we like to have lots of chunks. It's because that's what's needed to make the things work well, to get the physics right, to get the biology and the chemistry right. So where am I going with all this nonsense? Well, where I'm going is that we need to use these models to check out lots of ideas about not just the effects of habitat improvements, but the effects of climate change. To find out which of the things we really need to worry about big time, which things might be secondary. So I'm a fan of exercising these models a lot. And the people like me, or people who are younger than me but do what I do, that is, I go out in the bay and make measurements. And one of the things I like to do is to say, we've seen this. Does the model do that? Can the model do that? Those are great exercises, and they're useful, I think, both for stimulating scientific thinking, but also really helping with making management decisions. Trying to figure out what are the really, really important things, what are the things that we worry about less. They can be incredibly useful. So if any of you folks are interested in being right at the tip of the spear, do some mathematical modeling, get on board with that. That's good stuff, I think. Way beyond what I can do, but I think that's real important.
Kandis, I would make a quick comment that the good thing about the Chesapeake Bay program is it enabled us to think holistically about the watershed and what we would call a macro system of connected ecosystems. The drivers in that we're trying to regulate things like fishing and nutrients and other things are within that system. And so you can model that system and you can think about the pressures on that. The problem with climate change is much of the pressure is outside the control of those systems. They're not even within the jurisdiction of the United States or even the continent. It's happening on a global scale. And so the real challenge is to think about how to deal with climate change. It doesn't care which country, what political party, who's in charge, what policy you have. You know, the storm's coming and the fires are upon us and the floods are here. And that's being felt locally, but it's all being driven at a huge scale of a much increasing population and a hugely problematic dependence on fossil fuels. So that challenge is well beyond the Chesapeake Bay program and is going to be an enormous problem that in the next 30 to 40 years is got to be solved, or we're in a heap of trouble. We're already in a heap of trouble.
All right, thank you. Let's move on to the next question. And Mike, how about you take this one? What is the biggest challenge affecting the Chesapeake Bay? And you can give any example that you like.
Right, well, some of these have been touched on before. We, in open information, we actually had a telephone call to talk about what we were going to talk about, right? You know, this isn't exactly spontaneous, but except for Walter. But so you know, we had listed biggest challenges: nutrient strategy, cover crops, invasive species, nature-based solutions. But as has been talked about by my colleagues, the dial that is affecting all of those is climate change. Really, you know, I mentioned hypoxia. When it's warmer, the water is more stratified. You know, it's hotter at the surface and still cooler in the bottom. Well, that stronger stratification inhibits aeration of the bottom. Roughly, for every 1 degree centigrade it goes up, copepods, bacteria, the respiration increases 14%. So at the same time, the water is warmer. It has less oxygen. You could do this experiment at home. Put a pot of water on the burner and turn it up. All those bubbles coming out are the oxygen. So the water is warmed up. It has less oxygen, but the animals need more. So the nutrient strategy that we developed 20 years ago to cut out hypoxia by nitrogen and phosphorus and sediment reductions is a lot more right now because of the warmer water, right? It's increasing the respiration, and that's driving down the oxygen. At the same time, it's inhibiting re-aeration. So that's a huge problem. There's a great website called Climate Central. One aspect was developed by a UMSI's faculty member, Matt Fitzpatrick. And if you look in, it's like, okay, Salisbury, what is the climate of Salisbury going to be like in 25 years? Well, you're going to feel more like Beaufort, North Carolina, right? And Beaufort, North Carolina is going to feel more like Miami because of the heat. It would be great if we had a Bay Climate Central. So in 25 years, Chesapeake Bay could be more like Pamlico Sound because the eelgrass is going to go away, taken over by Halladooley. There's going to be a commercial shrimp fishery. We're going to see manatee and dolphin all the time. Right now, I see pelicans. I never saw pelicans when I got here, right? So this shifting biogeographic boundary influences fisheries management, biogeochemistry, pelagic benthic coupling, everything. And so if you're going to have restoration and make it better, you absolutely need to look through the lens of climate change. And as Mark said, they're starting to do this, but probably not enough, and it's a big problem that we can't solve. Despite the warnings of sea level rise, everybody wants to live near the water still, right? Dorchester County, where Horn Point is the county in Maryland that will lose the most land. The Harriet Tubman Trail is going to be underwater for many of the sites. Huge areas of Blackwater are going to be underwater. Even now, when at Horn Point, a person that worked with me would get a call saying the buses got to go to Hooper Island and pick up the kids now because it's a high tide, otherwise the buses won't get there. The EMTs move the vehicles out of the flood zone, otherwise they won't be able to get to the people they need. So this sea level rise, it affects the marshes, the animal, plant, and human communities, and it's a problem that goes across all economic sectors, all race sectors, and so that's, I think, the biggest environmental challenge that we face.
Thank you. Follow-up, Mark, do you have any comments?
You hit a lot of those. I think to pick up on one of them that Mike mentioned are two of them, because they seem to be in conflict a lot of time. We've got these natural systems that we're trying to protect, and particularly in relation to sea level rise, a tremendous push by development, by developed areas to protect structures against them, and it's that tug between those two. What links are we going to go to, and for how long, to protect the Port of Virginia? The answer is as long as we can, because it's big. How long is the Navy going to go to protect the largest naval base in the world, which is at Norfolk? I mean, they know eventually they're going to have to be somewhere else, but they're going to protect those things as long as they can. Maybe this, I don't know if this slides into one of our other questions. We're in a Maryland audience. A lot of people may not be following this, but Norfolk, with the help of the Corps, is proposed and planning to move forward with some real floodgates, some big floodgates, seawall and some floodgates. And as they present the plan to the public, it protects the port, it protects the naval base in areas, it protects some wealthy neighborhoods, and the poorer neighborhoods further upstream are left unprotected. And so this issue of, maybe I might have slipped into another topic on this, but this issue of what we choose, how when the things on your list that you were saying have different, are thought of as having different solutions or expensive solutions, or you can only afford them in some place. I see that as one of the biggest, hardest problems we face, both in the natural systems and in the built systems with sea level rise. Is, what do we protect, and for how long, and how do we help the places that we can't protect?
One of our scientists, Ming Lee, with one of the computer models like Walter described, had protected shorelines, Virginia, Maryland, all the way up. Okay, we're going to stop the sea level rise. And what happens to the water when it comes up? It all gets funneled to Annapolis and Baltimore. They didn't think it was such a good idea, right? So then, if you have, okay, we'll let the water slosh up relatively uninhabited areas, Blackwater. A lot of those uninhabited areas where people are at the lower economic rung, and so that whatever you do has downstream consequences. So you have to think holistically.
All right, good point. Ready for the next question, or Walter, you have a comment?
Just a quick. I'm glad to see a lot of young faces in here. That's very good. That's the next generation. So I assume you're probably interested in some kind of science, and I hope that you're interested in some kind of application of that knowledge. A number of years ago, one of my friends said, "Walter, we have an open position on the Zoning Appeals Board in Calvert County. Would you like to serve?" And without thinking about this, yeah, I said, it was so dumb. I said yes. And so I spent 10 years being beat up. And I often thought, if anyone wants to sort of pare down their list of friends, my Rolodex is just too big. It's got too many people in it. Be on a zoning appeals board, and you can prune them down pretty quick. Anyway, the point of this is that was my most incredible experience in applied ecology. Throughout the Bay region, it's these county zoning decisions that make such a difference. And they're probably going to make a bigger difference in the world of climate change. In Calvert County, we have 40 miles of shoreline along the main stem of the Chesapeake Bay, and we have an equal number of shoreline miles with the Patuxent River. So we have had over the years many cases that involved the critical area, and those cases range from absolutely simple things to really intrusive deals that would have some negative consequences. So I guess what I'm just saying is get involved. Sometimes it's painful and irritating and a little scary, but I think it's really worthwhile to take all this knowledge that collectively is in a room like this and bring it to bear on your local issues. So even more important with climate change.
All right, well said. I'm going to go to the next question, and we're kind of shifting a little bit to talk about social science or the sociology of science. And so when you think about this space, we need to educate those people who live in the Bay, who work in the Bay, and also who recreate in the Chesapeake Bay, as well as the entire watershed, about how fragile the ecosystem really is. So what are some key points that we need to communicate to the public? And who wants to start this one?
I'll take that on. I like to address two main aspects, I guess, of what I look back on, and I think of the sociology of the science and how it's changed drastically. The first is the problem that you see right before you. This is the problem of the past. Here we have 4 old white men doing all the science and driving all the questions and all the answers and telling us all how we should behave and what we should do, which is good. I'm proud of the things that we've done. But that's changed a lot more recently, and it's about to change more, I hope. There was a paper in 2018 that was an analysis of all the geosciences and the PhDs that were awarded from 1973 to 2016. That includes the earth sciences, the ocean sciences, and atmospheric sciences. In that time, 43 years in all of the United States, only 232 PhDs in the geosciences were given to African Americans. That's astounding. Only 627 PhDs were given to Hispanics and Latinos in that time period. Only 25% of those PhDs in that time were given to women. So that's an enormous problem if you're going to decide who's setting priorities and how you're represented. Now, I'm pleased to say that things are changing and have changed, particularly with respect to women. I've seen in my own group, and going from almost nothing in the 80s to nearly 50% of women in the research roles in my institution. And that's changing as they're gaining seniority. They're increasingly taking on leadership roles, not just participating. During that time frame, I would say 75% of our interns were women, but they didn't go on into the professional roles of leadership and serious science. And there's a lot of reasons for that have been discussed recently, but that's changing. So one thing is, it's a lot more fun, it's a lot more effective, and it's a lot better when you have diversity in problem solving. And that's critical, and we see some of that in the room. But the problem of underrepresented minorities is still huge, and that has not changed very much at all, even in the last 10 years. So we have a long ways to go, and we need to focus on that, and we need to make that change. The second thing is, how is the science being applied, as Walter is saying? Where is it being applied, and who's being affected the most? So we talk about these systems in rural systems that where people tend to be at lower economic income, and we think about this in terms of urban centers, like Baltimore and Norfolk and Hampton Roads and San Francisco and Miami and all those places that are the coastal cities where the urban estuaries are. Those are the folks that are impacted, and those are the lower income and mostly minority communities in those systems. And they need to be driving and setting the agenda, and we need to be adjusting to provide better results for them going forward. And we have not done that as well. As Walter points out, all the land use decisions are based on permits at a local level, at a county or municipal level. They're not made by the United States or by the Bay Program or by the states even. It's done at a local level. So the power of that is really critical, and all of us need to participate in that. So the sociology of that is changing, but having mentioned coming out of Berkeley and the demonstration time, you guys need to get going and make those changes by participating, not just protesting.
Mark?
I'll add, well, first I'll add that just the idea of thinking about sociology and it being part of it. We just recently filled or advertised for and filled 5 new faculty positions at VIMS. They'd been vacant, so they've been, due to retirements of some old white guys in a often narrow disciplinary science area. One of them, and the most recent one to have arrived, his PhD is in cultural anthropology, and it's about communicating with people and hearing their stories. And so the recognition of that, we burned one of our marine chemist positions or something that was vacant, but something we didn't fill in an old science because there was consensus throughout the institute we needed more social scientists there. Why we're not going to be a social science institute? It's much to do with the question that Kandis asked, but I want to change it a little bit because it actually says what do we need to do to communicate to the public? I think you have to fully. It's part of what Tuck was just saying. You have to fully engage with them. You're not communicating. Isn't how do we go tell you in the right language what you need to do? How are you engaged? How do we get those people that we think, gosh, if they'd only pay attention, the notion that you're going to dumb down a scientific paper and put it in common language, and that counts as good communication, engagement with, involvement of, and being on that local planning board. That has to start at the beginning part of that. That's not at the end of it when you've got the recommendations of what you want them to do. And to me, that's a mind switch. People were asking 20 years ago, how can we better communicate with the rural communities in Gloucester County or on the eastern shore of Virginia? And I'll take that and point out that we've got a few urban centers. The vast majority of Virginia's coastal zone is rural coastal, and most of the low-lying places are. And people are talking about how do we communicate with them? Where do we go talk to them? And what's the right language to use? But I think the switch now needs to be a complete mind switch, and is how do we bring them totally in at the beginning to find out how we're going to solve these problems, not how do we tell them at the end. So that's what I think is key.
All right,
I'll add one quick follow-up, which I think is interesting on the sociology of science, and it relates to collaboration. We've talked about collaboration at many levels, and that's the Bay program is super important about that. But when we were coming on as graduate students and postdocs looking for jobs, we were measured on first authored and preferably single authored papers. That was the thing that you really got credit for. Now, we have authorships that typically are 10, 20, 30, 40, 50 people that are collaborating at big scales and pulling together data from lots of different places and lots of different perspectives. It's the way science is being done at the scale and the opportunity to manage the volume of data and the types of technology and the impacts that are relevant to that. And so authorships reflect that much more now. It's harder to evaluate who is the kingmaker, but most of those people are actually signed on as acknowledging how they participated in each and every one of those papers.
Realizing this, we actually have a graduate course in team science. So the students take a Myers-Briggs test, so that everybody knows what their personality type is and how to build teams. And it's as much on trust and working with people as it is on science. And so that's, to make our students more effective at these group efforts that Tuck just spoke of.
Yeah, just to emphasize how much things have changed. I spent most of my career working with Mike Kemp, who's a wonderful, wonderful man. And when we were young and dumb and, very energetic, our lab directors explicitly told us, stop working together. You will not get promoted if you keep up that nonsense. You have to work individually. Anyway, being dumb and aggressive, Mike and I ignored it, and everything was fine. In fact, things worked out much better because we continued to work together. Just two other quick little things. One is, my wife is a mediator, and damn good thing that she is. Anyway, one of the things she keeps telling me about the successes they've had is, she said, you have successes when you let people tell their stories. And so one of the things about, I think, the sociology of science is arranging things so that people get to tell their stories. And she said often when that happens, the response you get from those folks is they say, well, finally, someone heard me. And then they're really ready to negotiate. The other thing is, just to yell out to the Bay program, which I like a lot. Yeah, you believe in
Of course
me.
I'm gonna say that.
Anyway, I recommend that they celebrate their successes more than they do. Those successes they've had, which are quite a few, they are not easy to come by. And I think celebration is called for. I know there are some scary parts of celebrating, like, for instance, some of the political people might think, okay, our job is done, let's move on. Well, I think in spite of that concern, celebration is a good thing.
All right, ready for the next question? All right, we talked about celebrations, but let's flip that to the other side of it. Is there anything that we've missed when it comes to the Chesapeake Bay? And who wants to start with this one? Mark, maybe?
Did I raise my hand on that one?
You sure did. What did we miss?
Well, leading off from what Walter just said, they got a lot right, because if you're gonna have to start listing some things that we missed, I want to start that a lot's been gotten right. I guess I think that fundamentally we miss the mark broadly sometimes by setting restoration goals or targets for the Bay by looking backwards, recreating what we had. What percent of historic oyster reefs or seagrass meadows that are we trying to restore? That said, we probably didn't have sufficient information to do much else initially, but clearly what we really should be doing, and I think is well understood now, is trying to define the ecological functions that we want to restore and the endpoints that we want to achieve in recognition of where we are. Double the number of people in the watershed, as somebody said, I think maybe Tuck. Climate change. What do we want the Bay to look like in those things, technically? Because it might not be, it's not going to be with the same species in some cases. I mean, there's different fish here already. If you really, really want to get the amount of summer flounder they're coming up the coast, they're not coming into the Bay as much. The center's moving forward. That's true for a great many populations. You're not going to get there by looking backwards, because that's changing. I mean, so we don't get to turn the knobs as part of the Bay program on climate change issues. We don't get to really slow down the development. So starting at the other end, what are the functions we want? What are the things we need? What do we want to preserve? And sometimes, to say this, putting some reasonable, if you use the word zoning, you get in trouble, but understanding that all parts of the Bay are not equal. In Virginia, we have a zoning of the Bay. It was done by Lieutenant Baylor's maps from the 1890s. So sort of where you can lease bottom and where you can, and that's the zoning. In Maryland, you have a similar thing too. I mean, we need to look at those things and think about the ecological functions, the ecosystem services, a squishier term, that we want to achieve, and where we can achieve them, and do that as opposed to what percentage of the past is my sense. And I already got this, already snuck this other one in. So I'm trying to do that again. We didn't miss the climate change thing, but we sure got out of the gates a little late on that. And I think mostly, I don't think it was because the scientists didn't know it and recognize it, or the Bay program didn't know it or recognize it, but it was a hard political sell. that we got to do this much more work, because it is going to be worse because of climate change. You know, the folks, if the folks that are funding this aren't going to listen to that message, you can't scream it too loud without losing. So I guess I'll add one other thing, because I don't know where else it'll come in that we might have missed the mark on. And now this will get back to being down and local. When the Bay Act agreement was signed, and when states and then localities started putting in place regulations and ordinances of how to implement it. And a lot of this is done at the local ordinance level, you know, working under a regulation at the local ordinance level. The thought was, what's the quickest, easiest, most cost-effective way to reduce sediment and nutrient runoff, right? What you're gonna do in your private property. And particularly local ordinances got put in place that were simple to do and simple to understand. Don't do this in the resource protection area, period. Boom, don't do it. Maybe you could get some exceptions to it by going to the local bay boards or something. If we were thinking at the same time, which we weren't, about climate change, particularly about sea level rise, and about the interest of the property owner as well, and made more nuanced or flexible ordinances. I don't mean flexible in that you can do something that's going to increase the sediment runoff or the nutrient runoff into the bay. We still want to do that, but we didn't think about how could we do something that could also help protect somebody's house. A house that's not going to be there in 60 years, but in 30 while they're paying their mortgage. What can we do? And then offset, and how can we offset those impacts? So I think there's a lot of work to be done at the state level first and at the local level which there's often resistance to dig into these ordinances and say, how can we meet the dual goals of the Chesapeake Bay program, the clean water and reducing runoff and sediments and nutrients, and the goals of the property owner to be able to protect their property and mostly I'm thinking of some new things out there that are innovations. Well, some of this we're going to have to innovate our way out of. And how can we do that? And in the context of those ordinances and regs. And we can talk specifics about some of those new innovations at another time. But.
Okay, so the question is, what did we miss? Tuck or Walter, did you have any follow-ups?
Yeah, I would have two quick things. One on the science, and an example on the science, and one on the sort of sociology aspect of this. On the science, I think that we still barely appreciate the connectivity of these coastal systems in Chesapeake Bay. And I'll use an example of that. Something like 230 or so, 235 species of fish that are commonly in Chesapeake Bay every year. Of those, 200 of them have migratory life cycles. Many of them are migrating outside of the Chesapeake Bay and along the coast. Conno's rays are going every year from the bay down to Cape Canaveral and back again. The same ones are coming back to the Chesapeake Bay. You think of salmon or something like that, but this is a repeated cycle. River herring, we just had tags to river herring that are reported from Maine coming in and out after spawning in Chesapeake Bay. So those are examples of the connectivity and the scale of that were being barely understood. And we focused on the few lucrative fishery species for the most part, and ignored the vast majority of the species and biodiversity of the system. It's the biodiversity and the ecosystem health that are really important to supporting those fisheries rather than trying to manage one species at a time. So that's a science. The second thing is the sociology of this. You know, we talk about change. We talk 40 years of the Bay program and how climate change, Mark said we were too late coming out of the gate. At CERC, at the Smithsonian Environmental Research Center, we have an experiment that's 37 years old on the effect of rising carbon dioxide in natural plant communities. It's the longest running experiment of its kind in the world. And it clearly shows climate change and effect of carbon dioxide on salt marshes, on wetlands. And when I present that to folks, they say, well, you know, you guys are too slow. It's taken 30 years to begin to appreciate that. You can apply that to the nutrients, you can apply it to invasive species and ballast water, many things, 30 years. It's too long. And I point out to folks, no, we started 30 years ago. We saw it 30 years ago. The science was on it. You're too slow. Our problem is that we didn't communicate effectively to you. And we need to engage, especially business. I am as frustrated as everybody else with politics. We're about to have a government shutdown, or maybe not, or who knows what's going on in Congress. But if you communicate with business, you know, no more insurance policies are being issued in the state of California. No more insurance policies are being issued in the state of Florida. Whole states. Think of the economic impact of that. How fast is change going to happen with respect to how climate change is viewed in those states? Not 30 years. 3 years. You will not get another mortgage, a 30-year mortgage out of those companies because you can't get insurance. So that's where we need to be emphasizing interaction with business and getting them to understand and apply the solutions at the economic scale, not the companies that come in and develop a strip mall or a 10-home development and 3 or 5 years and get their money and leave. You want the companies that are investing for 30 to 50 years, and those are oftentimes the insurance companies.
Like the military.
The military is great.
Exactly.
Yeah, exactly. You know, how long is the military going to stick with Norfolk? I don't know. That's a great question.
I think it was either 1985 or 86 they discovered an internal memo at Exxon saying that, our products are increasing the temperature of the earth, right? So we've got to start some counteracting of communication, right? So scientists have known this for a while, but as we pointed out, we haven't communicated it very well. It was only a decade ago that less than half of Americans believed in climate change.
A real quick follow-up to Tux, if we got a minute. I'm not going to give us credit for it because we didn't necessarily recognize it at first, but it turns out a member of our foundation board, because we've all got boards that help you do things like raise money. It was really connected in sort of the financing side of large developments. He was a member of our board, and he saw a presentation from one of our scientists, a modeler with really advanced modeling capabilities, that the ability to run these models maybe with the wind speeds from Hurricane Floyd or something, or any one of them, but on top of sea level in 2050 at high resolution, really great models, and all of what was going to be at risk with this and how you could predict that. And he was so interested in that and so interested in how that was used as a planning tool that he started this series before the pandemic in which he would bring, brought a few people that in the real estate development industry in Hampton Roads, some of them up from Richmond, some that finance this stuff, and we did some in person through the pandemic, which is how we measure everything now, right? Before, during, and after, or maybe someday after. We continued that with his impetus online, usually groups of 6 or so that he'd get together. We've put that modeler and others, you got to teach the modelers how to speak in things other than partial differential equations, but and how to speak to them. But we've put that now in front of, I don't know, 50, 60, 70 people really working, high level that work in that finance area. And insurances have gone to it, and it's been really well received. They keep coming back as they build that in demand, and that wasn't our impetus. We didn't think to do that until somebody who was on our board suggested it.
All right, ready for the next question? So we asked about what did we miss? So the next question is, what were the surprises? So Tuck, if you want to start with this one, what were the surprises, or were there any surprises in research or engagement with the Bay communities?
Yeah, I mean, a lot of us as researchers, science are driven by that surprise, the aha moment of figuring something out, which is really intrigues me and a lot of the work that I did. When I came to Chesapeake Bay, for example, nobody knew what a blue crab did every day, yet it was the most important commercial fishery in the bay after oysters had undergone their demise. And I was completely flummoxed because I'd been working in Hawaii and in California in systems where I could see even on a bad visibility day diving, I could see 10 feet and I could watch things. You can't even see your hand in front of your face in Chesapeake Bay. And so I had to figure out how to apply telemetry to understand movement of blue crabs, and I had some really, and what they were actually doing. And I had some great colleagues that helped me do that. So the technology is constantly providing surprises and insights into that. And most of us as ecologists are way underfunded. We talk about big programs and everything, but compared to medicine and space programs and the military and all of that, ecology and environmental sciences are way underfunded. But what we're clever at is taking somebody else's gizmo or thing and applying it in a new way to solve problems. And so, we do those kinds of things, and that leads to surprises that are really, really valuable, I think. And so I won't mention many of those, but I think there are things that suddenly we're realizing, like microplastics, the amount of plastic pollution going into the oceans. We recently published papers on the garbage patch floating out there in the mid North Pacific, and a whole community of organisms that are now living on those. And the transport of those things, plastics floating in bottles and everything around the ocean. So all of that is coming down mostly from rivers through Chesapeake Bay and out into the oceans. So understanding those connectivities and to be attentive to that. I think those are the kinds of surprises that I'm seeing, and the frustration that I've had, surprising frustration of how to increase diversity and participation by more people and more diverse people in the sciences and in the work that we're doing, has been on the negative side of surprises. It just shouldn't be that hard. It's really not that hard. It should be easier.
All right, any follow-up?
Well, Tuck mentioned, the surprises. I mean, we didn't think climate change was more theoretical when I got here, but we're up to our knees in it, literally. Blue catfish. Many estuaries have invasive species. I think for engagement, and a positive engagement, is when I came here, we had the Chesapeake Bay Foundation, and that was one of the first organizations nationwide. Afterwards, there were Friends of Puget Sound, Friends of Long Island Sound, but CBF was really the first. In our little town of Easton, you could go to this environmental office, and there's the Eastern Shore Office of Chesapeake Bay Foundation, Shore Rivers, which is an offshoot of the River Keepers, up and down the rivers of the Eastern Shore. The Nature Conservancy has an office there. Ducks Unlimited has an office there. And so we're blessed with a lot of environmental organizations that do great science that we partner with, that are potentially good opportunities for jobs and a fulfilling career for some of you there, that I think has made a difference in communicating science, getting people involved, from sampling bacteria and secudus off their dock. So that citizen science is very strong in Chesapeake Bay, and I think that's been a great addition over the last 10, 20 years.
All right, I am looking at the time. So we said that we would have a Q&A session. So unless there's any final thoughts on this question, the surprises, I'm going to open it up and see if anyone in our audience has a question for any of our panelists. Yes, sir.
The natural process of climate change has been with us for billions of years. How do we distinguish what percentage of climate change is natural, what percentage is man-made, on a global view?
It's a great question that the public perceived, because it's still happening at a relatively slow rate compared to the daily rate of life of a human. But they're starting to get it, because almost every week now it's coming at them. And all that science has to do is plot those data. Look at the temperature rise, look at CO2 levels, all of those things. It's very clear to a scientist. But the folks that won't look at that, it's a real challenge to communicate that effectively.
But how do we, Hurricane Agnes creates species change.
Well,
the height
shifts.
of the water level has, for millions and thousands of years, changed. Medieval times,
It's
Ice
the
Age,
rate
all
of
this
change.
is
We can,
natural.
no, there actually is an
How do we
answer
know?
to that. And it comes not from marine ecologists, it comes from geoscientists and geologists. We know now what caused the great heating that occurred in the Permian. It was, and the extinction and a huge amount of heating in greenhouses, because there's records in globally of the ash layers from the huge amount of volcanoes. So we know that greenhouse gases were spewed into the air then, and they didn't come from us, right? In the Permian, the body of evidence is really large. We know when there are other fluctuations. We know we've had ice ages before, and what's going on then, and then what warms them up. So sea level's been rising, some ups and downs, since we got past the peak of the last glaciation and things started melting. But that's not what's driving this recent change. There's a really strong correlation of what we've at this point been putting the greenhouse gases into the air for this time period. Correlations alone still aren't enough, but we know the chemistry of it. We know the physics of it. It is hard to communicate.
So how do we know it's not a dual process? How do we know we're not in a natural change? Also,
Because we don't see other natural cause. We know the natural causes when we see them, right? Now part of the thing is, one of the things, there are times that it's warmed up in the past.
Never this quickly, though. Never this quickly.
Never this quickly.
In my lifetime, one of the advantages of being an old geezer is I was living when they started measuring CO2 at the top of Mauna Loa.
Yeah.
And we've increased CO2 in the atmosphere in my lifetime over 30%. So if you look at the Rostock ice cores, and nowhere in geologic history has CO2 increased that rapidly. And that's, you're absolutely right, it's happened before, but not that quickly. In concert with it is the higher temperature.
so it could
Another
be both.
question.
It could be natural and man.
We need to get some other
Okay,
questions.
so, yes, thank you so much. I have a speakers list. All right, so let's go here to my left. You had your hand up? Yes.
So I really appreciate, I'm a rural sociologist, so I really appreciate the conversations that you've had about sociology and being part of the science, and being integrated into the sciences, and also the importance of rural areas in land use decision making. You also talked about the gaps in the science that you have observed. I wondered if you could speak for just a second on the gaps in the social science that are being addressed, and what you see as in the future in terms of resource needs, technical needs, and the science that needs to happen in that particular realm of social science.
Well, first of all, we're not social scientists. So that's a shift right there, the emphasis on social science. So I think it is important, but I will say to that, we're in the process of recruiting new scientists, a new generation of scientists coming in, retirement of us baby boomers. Those scientists, those natural scientists, are in fact applying and using and collaborating extensively with social scientists themselves. And so it does have a different perspective, but it is broadening the way you and Walter talked about engagement and participation and application of our science, rather than the sort of previous generation's view of pure science. And so I think part of that's driven by the economics of the funding sources, right? NSF expects to engage socially, expects to engage applications and all that. But we're still struggling with that issue.
All right. Any follow-up? Because we have time for one more question. All right. In the back, you had, yes. Yes.
Hi. So I was thinking about how the world, as time has moved on, has become increasingly globalized and more dependent on these really broad networks in different places. And we're very place-based here in Chesapeake Bay. But there are more and more scientific networks too, of different groups collecting
Well, one thing that changed in my career is when you write a proposal, you have to have a data management plan. And so even if it's in Chesapeake Bay, it goes in a national database. And I could access data from San Francisco Bay and Galveston Bay and Puget Sound. So, and then people are taking advantage of that to do more synthesis. And as you know, Becky, we have these estuary conferences, and there'll be topics on hypoxia, and you see what people are doing from different areas. So, I mean, I think it is happening on a scientific level more so than before.
You know, another aspect of that I think is really, really important is that because we have data available from lots of different places now, we can put it together in useful ways. We call it comparative ecology, and look for commonalities. And so, for example, in the early fight over should we control just phosphorus or phosphorus and nitrogen, people used that approach, and that was one of the ways, in other words, dealing with data from lots of estuaries that said, you know what, it looks like it's an N and P issue. So by going the comparative route, we are able to talk to policymakers to say, you know, this is not just a local little problem. This is something we see everywhere. It provides some confidence that they are on the right track.
All right, so with that, I want to take a moment to tell each of our panelists thank you. Can we give them a round of applause? And, you know, some of the takeaways that I am going to capture, not only for now, but in the days and weeks to come, is how Mark said that communication is about engaging. Tuck said that we need to focus on diversity, and diversity in so many different spaces. Walter said, tell your story and get involved. And then Mike was talking about we need to think about climate change and its impacts. So I say to each of you, tell your story. We have a 15-minute break before our breakout sessions. Also, you're welcome to come and talk to our panelists throughout the day. We also have the lunch session and the poster session as well. So we'll ask our panelists to please stay. We want to take a group picture. But I'm going to ask Steve, anything else before we break for our 15-minute break? All right, you have a 15-minute break. Thanks, everyone.